Welcome to tonight's video on Unit 8. We're going to do Part 2, talking about right triangle trigonometry. First of all, the six right triangle trigonometric definitions are, remember sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and the cosecant is the reciprocal of the sine, so it's hypotenuse over opposite. And then secant is hypotenuse over adjacent. And cotangent is adjacent over opposite, right? And remember, that's in a right triangle where theta is one of the acute angles, so you would have adjacent opposite, and the hypotenuse is always opposite the right angle. Some things to be aware of: sine, cosine, and tangent are functions of angles. Do not say sin, cos, or tan. They're pronounced sine, cosine, or tangent. Present your answers with a table, like whenever you have to find the six trigonometric functions. And notice that three functions in the right-hand column are the reciprocals of the three in the left. And then you'll also notice that the ratio of sine over cosine is tangent. The same is true for cosecant, secant, and cotangent. So we'll talk about what that means as far as reciprocal and quotient identities later. So some special right triangles, remember 30 degrees. So if we draw the angle in standard position, and then we draw the reference triangle. Remember, that's 30 degrees, so opposite the 30 is always the 1. But in this case, it wants the hypotenuse to be r. So then this is going to be r over 2. And then opposite the 60 is always rad 3 bigger, so it's r rad 3 over 2. So when you do the sine and you do opposite over hypotenuse, you're going to get 1/2. When you do the cosine and you do r rad 3 over 2 over r, you're going to get rad 3 over 2. Tangent, when you do r over 2 divided by r rad 3 over 2, you're going to get 1 over rad 3, which is rationalizes to rad 3 over 3. For the reciprocals, you just flip 1/2, you get 2. Flip 2 rad 3 over 2, you get 2 over rad 3, which rationalizes to 2 rad 3 over 3. And then for the cotangent, 1 over rad 3 rationalizes or flips to rad 3. All right, so those are your six trigonometric functions. You could do the same thing for 45 degrees. So that's theta. So then you have, this is r, so then you have r over rad 2, which is basically r rad 2 over 2 when you rationalize it. So then, when you do r rad 2 over r rad 2 over 2 over r, it's going to give you rad 2 over 2. Same thing for the cosine. The tangent, notice you're going to have r rad 2 over 2 divided by r rad 2 over 2, so you're going to just get 1. The reciprocal here of rad 2 over 2 is just rad 2, because remember, really that was 1 over rad 2. Same for the secant. And then the reciprocal of 1 is still 1. So that's the 45 degree. For the 60 degree, where it's pi over 3, So here's theta, and then you draw a triangle. So remember the hypotenuse is r, and now this is going to be r rad 3 over 2, and this is going to be r over 2. So now the sine is r rad 3 over 2 over r, which is rad 3 over 2. The cosine is r over 2 over r, which is 1/2. And the tangent now is r rad 3 over 2 divided by r over 2, which is rad 3. So then you take the reciprocals. The reciprocal of 2 over rad 3 over 2 is 2 over rad 3, which is 2 rad 3 over 3. And this is 2. And then 1 over rad 3 becomes rad 3 over 3. All right, so for what geometric concept supports the fact that no matter what the length of the ratio is, or the r value, that the 6 trigonometric functions will always result in the same ratio, and that is that similar triangles have corresponding sides that are proportional. So labeling triangles, so we're always going to label the vertices A, B, and C. In a right triangle, C will always be the right angle, and then opposite that vertex will be the side. So side A is opposite vertex A, side B is opposite vertex B, and the hypotenuse is C. And then also the angles, alpha will go with vertex A, beta will go with vertex B, and gamma with vertex C. Some just things to keep in mind: the longest side of a triangle has to be less than the sum of the other two sides, and the longest side is opposite the largest angle, and the shortest side must be opposite the smallest angle. When you're solving right triangles, you can use the right triangle definition, SOHCAHTOA, finding the unknown lengths and sides. Draw a picture, and that's number one. When possible, use only the given information because that's not rounded. So remember, we're going to round our answers if there are decimals to 3 decimal places. So if you use the non-given information and it's rounded, then your answers could be off. And always present your answers in the following table. Angle of elevation. Remember, the angle of elevation is the angle at the bottom looking up to the object. The angle of depression is from the top down, but notice they are the same because alternate interior angles are congruent because these lines are parallel. Bearings used in navigation. There's 2 ways to look at bearings. One is from the north. So if you draw here, and remember north, south, east, west. From the north, so if there's no directional thing, then you assume it's from the north. So you'll start here and go 192, so 180, and it goes to there. So the angle, and now the angle is always drawn from the origin. It's just the direction goes from the north. So that would be 192 degrees. So if you're going 294 degrees, so if you're going 294 degrees, you start at the top here, and you go 90, 180, 270 to there. So that would be about 294 degrees. All right. So now, the next way we can do it is from the north-south line. So from the north-south line is when they give you directions. So for example, the north-south line is up and down, right? And then you have west, east. So if they say south 40 degrees east, that means you go from to the south and to the west. Sorry, 40 degrees west. So you go southwest, but the direction, the 40 degrees, is taken from the north-south line. So it's there. Whereas here, if you're going north 35 degrees east, so you start and you go north 35 degrees east, but the 35 degrees comes from the north right there. All right, so that is bearings. All right, so when we use our calculator and when we don't, so a couple things to keep in mind, or when do we have to and when we wouldn't. So first of all, you must provide an exact answer. What you plug into your calculator is an exact answer, as well as the decimal approximation if you're using your calculator. You're going to round to 3 decimal places, and remember, beware of the mode degrees versus radians. All right, remember, make sure if your calculator needs to give degrees, that you're in degree mode, and if it needs to give radians, you're in radian mode. So make sure you check there. So if you want to change the mode, you see the calculator here, you just go to mode and then make sure in this line here, if you want to be in radians, then you go to radians and hit enter. If you want to be in degrees, then you click on degrees and hit enter. All right. So calculator or no calculator in this case, when you're trying to find the measure in radians, see this tells you that you need it in radians. What angle gives you the sine of 1/2? Well, that is a special right triangle, so you don't need your calculator. You don't need your calculator for that because theta would be pi over 6 or 30 degrees. But you want to leave it in radians because it tells you. Here you would have to use your calculator because 2/3, where the hypotenuse is 3, is not a special right triangle. So this means that you would have to go theta equals sine inverse of 2/3. Make sure your calculator is in radian mode, and you would get 0.730 when you round to 3 decimal places. Same thing here, you would have to use your calculator for the next one. Now this is in degrees, so make sure your calculator is in degree mode. It's degrees because you can tell there. Tangent inverse of 7/5 is 54.462 degrees. Calculator or no calculator. For the next one, you would not need a calculator because that's a special right triangle. The cosine is 30 degrees when it's, sorry, the angle is 30 degrees when the cosine is rad 3/2. All right, for the next one, finding the values of all 6 trigonometric functions of theta, the first thing you want to do is find this missing side here. So you got to do the Pythagorean theorem. So you're going to get that it is 88, or square root of 88, which is 2 rad 22. So we'll find the 6 trigonometric values of theta. So it's 2 rad 22 over 13. Cosine would be 9 over 13. And tangent would be 2 rad 22 over 9. Cosecant, you take the reciprocal. Well, you have to rationalize, so you have to multiply by rad 22, so you get 13 rad 22. Rad 22 times rad 22 is 22, times 2 is 44. The secant is the reciprocal there. And the cotangent is reciprocal here, so it's going to be 9 rad 22 over 44 when you rationalize. All right, assume that theta is an acute angle in a right triangle. So if you draw the right triangle here, and let's say we put this as theta, then the secant is 3, so it's 3 over 1, and we still have to find the missing side, which when you do the Pythagorean theorem, you get that it's the square root of 8, which is 2 rad 2. So we go sine of theta is equal to 2 rad 2 over 3. Cosine is equal to 1/3. Tangent is going to be 2 rad 2 over 1, which is just 2 rad 2. And then the cosecant is 3 over 2 rad 2, which you rationalize to 3 rad 2 over 4. The secant we already know is 3, and the cotangent is 1 over 2 rad 2, which is rad 2 over 4 when you rationalize. All right, number 7. So now we want to draw our picture because this is solving a right triangle. Solving a right triangle. So here we're going to make this A, B, and C. So that means that alpha here is 32.5, and this is 90, and then the side opposite is 26. So here's B is down here, and then C. So now we have to make our chart. So we want alpha to be 32.5, beta, and then gamma we know is 90 degrees. We know side A is 26. We want to find side B and side C. Well, beta is equal to 90 minus 32.5, which is 57.5 degrees. All right, so now we have to find B and C. Well, we can set up a trig ratio. We can say that tangent 32.5 is equal to 26 over B, and then you just multiply and divide, so B is equal to 26 divided by tangent 32.5, and you get that is approximately 40.812. And then you could do the same thing for C. You could do that, and we'll just do sine. So sine 32.5 is equal to 26 over C. So that means C is equal to 26 divided by sine 32.5. And you would get that it is 48.390. All right, so that's solving a right triangle. Now we can also use SOHCAHTOA for word problems. Like for example here, it says there's a lighthouse that stands at the top of the vertical cliff. So here's our lighthouse, and it's 25 meters tall. And then there's a boatman that observes them. One, he looks at the bottom of the lighthouse and says it's 24 degrees to there. And then he looks at the top of the lighthouse and it's 28 degrees to there. So then how far from the bottom of the cliff? So we'll say x is his distance. That the boatman is from the cliff. Now we'll also have to know the height of the cliff, so we'll say that's y. We'll use that to help us solve. So now, when we do this, we have two triangles. We can say tangent 24 degrees is equal to y over x, and we can say tangent 28 degrees is equal to y plus 25 over x, using the big triangle and the small triangle. So now if we solve both of these for y, we get x tangent 24 equals y, and we get x tangent 28 minus 25 equals y. So we set these equal to each other. Because they're both equal to y. We bring the x's over to one side. And then divide. 4 minus tangent 28. All right, so we divide that all, and remember it's in degrees, and we get that x is equal to 289.082 meters. So that's how far the boatman is from the bottom of the cliff. So for the base of the isosceles triangle, remember isosceles triangle has two sides congruent. So the base is the non-congruent side, so we'll say it's 48.8, and the vertex angle is 38.6, and this is x and x, so that's the leg of the isosceles triangle. And remember, when you draw an altitude, that you divide the isosceles triangle to two congruent triangles. So here's 24.4. This angle is 19.6. So to find x, you can make a trig ratio. So sine 19.3 degrees equals 24.4 over x. And then you can just multiply and divide. So you get x is equal to 24.4 over sine 19.3 degrees. So x is equal to 73.824 meters. All right, so identities. Last thing we're going to talk about here. So remember the unit circle, right? Unit circle with the radius of 1. Right? Radius of 1, that's the unit circle. Now, if it intersects a point on the circle, x, y, and so if you draw the reference triangle, this is x and this is y. So if you do the Pythagorean theorem, you get that the equation is x squared plus y squared equals 1. Notice that if you did trig ratios, opposite from the reference angle here, opposite over hypotenuse is y, adjacent over hypotenuse is x. So substituting that into the equation would give you that sine squared plus cosine squared is equal to 1. So that is the main Pythagorean identity, sine squared plus cosine squared is equal to 1. So there are other versions of this. You can manipulate the equation of sine squared plus cosine squared equals to 1. For example, the first one, you just moves cosine over. So you get sine squared equals 1 minus cosine squared. And then you could do the same thing with sine squared, so you get cosine squared equals 1 minus sine squared. You could also divide by cosine squared, sorry. So if you divide, you get tangent squared plus 1 equals secant squared. That's if you divide by cosine squared. If you divide by sine squared, well, first let's manipulate this one. So if I move the tangent squared over, I get 1 equals secant squared minus tangent squared. And then if I move the 1 over, I get tangent squared equals secant squared minus 1. Then if I go back to here and I divide, instead of by cosine squared, if I divide by sine squared, I get 1 plus cotangent squared equals cosecant squared. And then if I move the cotangent squared over, I get 1 equals cosecant squared minus cotangent squared. And then I also get that cotangent squared is equal to cosecant squared minus 1. All right. The reciprocal identities, remember sine is the reciprocal of cosecant. Cosecant is the reciprocal of the sine. Cosine is the reciprocal of the secant. Secant is the reciprocal of the cosine. Tangent, reciprocal of the cotangent. Cotangent, reciprocal of the tangent. The quotient identities, tangent is sine over cosine, and cotangent is cosine over sine. All right, so the last thing is proofs. Remember, we are going to start with one side of the equation and rewrite it. And then we're going to substitute algebraically. So for example, here I'm going to start with the left side. So tangent theta, cosecant theta. And then I'm just going to go down. I'm not going to, it's not equals. I just want to make it prove that the left is the same as the right. So tangent is sine over cosine times cosecant, which is 1 over sine. Sorry, I got to change it to 1 over sine. And then when you multiply, you get 1 over cosine, which is secant. There you go. You've shown that the left is the same as the right. No equal sign necessary. Notice no equal signs. So same thing here. Now here I'm going to start with the right. I'm going to multiply cosecant plus 1 times cosecant minus 1. And that's going to give me cosecant squared minus 1. And that's going to give me cosecant squared minus 1, if you remember, is the same as cotangent squared. And there you go. All right, that concludes our video. Hope you enjoyed that one and have a good rest of your day.